What was the vision behind Composer?
At Cursor, we had a previous model, Cursor Tab, which was our autocomplete model. And it's one of the most popular features in Cursor. I think developers really like it because it's really snappy. It's kind of a delight to use, and you can kind of get your vision done quickly. So we wanted to build an agent model that had similar properties. We wanted it to be really smart and good at coding, but also really fast so that it would give you an answer quickly that you could iterate on and kind of provide more feedback as you went.
That was my first impression. I was playing around with Cursor 2.0, and the first thing I said literally was, it's blazing fast. Was that like an intentional decision?
Yeah, it was something that we found really changed the experience, that if the model was fast enough, you could really kind of keep in the flow of coding. That being said, there were other fast models that we had seen released before, and we felt like they weren't kind of at a sufficient coding quality that we felt kind of comfortable trusting them. So we wanted a model that we thought was smart enough that we could trust to write code for ourselves, but also fast enough that it felt really snappy.
Because I know I was reading in the announcement, like some of the architecture decisions, right? Mixture of experts and reinforcement learning. What was the thought process as far as the decisions there?
Yeah, so I think we've seen a lot of models that really focus on having just general ability, that they're good at writing essays or they're good at kind of giving you dating advice. And we really thought we could build a model that was just very specialized for doing one thing, which was being kind of an agent model for coding. And reinforcement learning is kind of the tool that allows you to do that, where you kind of don't need to just train on the web, but can focus on a specific sub area and build a kind of specialized model that kind of just kills it at that one task.
This is an agentic experience, right? So it's different than like a simple LLM, right? With reinforcement learning. So how is that different as far as building it?
Yeah, so I didn't really get a sense until I started kind of working on coding models how crazy some of these agent systems are in terms of how powerful they can be in their tool call use. We see models that casually call 150 tools to try to answer your question. And so we think kind of as these models get better and better in different areas, they're going to be kind of both smart in what they do, but also very smart in how they find information. So if you have a very large code base, they're going to be calling tools to do search. They're going to be calling tools to run terminal commands. And they can do a lot of stuff that maybe a human would get bored of or kind of stop doing to try to find their answer. So for us, the agent power of the model is really just the kind of persistence in trying to find the answer that you're looking for.
I know that you're built with PyTorch and Ray. What libraries have you used or
yeah,
have you seen
for
work
sure.
or not work?
So particularly for the agent part of the system, what we found was critical is that this model basically has to run a full version of Cursor as part of training. So we basically were able to encapsulate all of Cursor in a kind of virtual machine and then launch hundreds of thousands of these virtual machines so that we could do training. And it has to basically be like Cursor because we wanted to simulate what a real user experience would look like. And so getting the infrastructure to really make that work required kind of scaling that up, making sure it could be stateful, making sure it was robust. And that's a kind of specific challenge to RL that we don't see in other sorts of training.
Yeah, there's a big distributed computing aspect probably there. What other parts, like which libraries? Was it Ray, Data? What was what worked? What did it kind of that in that sense?
So we use Ray all across our spectrum.
Nice.
So I think there are 5 places we found that we're like explicitly using Ray in this whole process. The main one is that Ray has become a kind of standard way of doing the RL controller. So basically writing the code that controls the RL rollouts that you'd use. And Ray's a nice choice there because when you're doing code rollouts, you could do, say, 100 of them, and they're all going to take a different amount of time to finish. That's because some of them might get to the answer quickly, or others might run terminal calls or things like that. And kind of controlling that whole process with Ray was nice. We also use Ray Data for a lot of our data processing. So there's all sorts of kind of different data processing that goes into the RL pipeline. One of the systems that we built internally was using Ray Data to analyze the results. We have all these rollouts at scale, and we want to see which ones are winning, which ones are losing, what looks good or what looks bad. And we can very easily spin up a Ray Data job to go over all of our rollouts, call LLMs to analyze the different results, and try to understand what's working or what's not in that setting.
It's like very exciting to hear the different use cases as well. As far as that journey of building a frontier model, what was that like for you?
Well, it's been fun. I mean, I think the scale of the systems that people are building now are really remarkable. This system involved thousands of GPUs and probably way more orders of magnitude even of CPUs to get it working. And it's been a really interesting process. I mean, I think one of the things that's been really fascinating about building this sort of specialized model is at Cursor, we're big users of Cursor. And we have a sense of what it is that we want in a model, like how we want it to behave, how we think it would work. And we have a good sense of what users are looking for. And so building a model in 2025, it does involve a lot of kind of product choices of how you make it behave in the right way or do interesting things to make it work well for the users. So we talked about speed, for instance. Like one part of speed is just generating quickly. The other is the kind of wall clock time of actually using it in practice, right? And so you want to build a model that does parallel tool calls or chooses the kind of correct way to use the context that it has. And so kind of combining the ML research parts with the specific kind of product questions of building models.
Because it definitely felt intertwined. I was using Cursor 2.0, like even, right, you have the agent view and you could see the parallel agents and like the timer. It's very like, it seems like very intertwined with, there's a strong relationship between product too.
Absolutely,
and it's fantastic.
Yeah, I mean, Cursor is one of these kind of new generations of products where they're kind of AI native in a way, right? It's kind of built in. So there's kind of conversations day to day between people building the system, people using the system, people doing the machine learning. It's all kind of one group.
Also, regarding mixture of experts, for someone who doesn't understand mixture of experts, how would you explain it to someone?
Yeah, so before I worked at Cursor, I was a professor and I would teach classes on transformers and language models. And we're in about year 8 of transformers being like the dominant architecture in almost everything in AI. And really not too much has changed from the kind of core transformer architecture. The one exception of this was mixture of experts. So mixture of experts is a kind of architectural change to the core transformer, where instead of having a standard neural network in one of the layers, you instead have a set of distributed neural networks. And every time through the model, instead of touching every parameter, you instead choose a subset of them that you use. And there's several benefits to this. One is that you don't end up kind of paying the computational costs for all of them. But more importantly, it allows you to distribute your computation. So when training these models on many GPUs, we can basically shard the experts onto different GPUs and use only the ones that are necessary for that run. And so that's kind of an instance of where the kind of machine learning and the systems parts have kind of gotten together to try to kind of find the most efficient architecture.
I could tell you were a professor. You explain it so well. Also, as far as advice for how to use Composer, let's say now if you're a developer using Cursor 2.0, what is the way you would advise them to play around with Composer?
Yeah, it's a good question. So I like everyone else, I'm trying to figure out the best way to use this.
We're all figuring it out.
One thing I've seen a lot of people talk about online that seems to work very well is to have a slower model work in what's called plan mode. So we have this kind of mode in Cursor where you can ask it to draft a plan for a big change that you'd like to make. And then it kind of thinks for a long time, comes up with a strategic plan. And then you have a model that's a lot faster, like Composer, go and implement that plan in practice. It's good at kind of taking the direction, going in and kind of kicking it out. And because Composer is so fast, you can kind of correct it as it goes or maybe jump in and change something on your own. So I think that's one direction we've seen is really nice.
And do you feel like there's going to be a lot of mixture of models for different use, like in how we'll use things like, that are very specific to a use case, right? Because I love how you could actually select, but there's a lot of flexibility in the product, right?
Absolutely,
I love that I could select multiple, I could like whatever, and iterate. For iteration, though, as a developer, I loved how Composer, the speed really makes you be able to test. Is that why? Is it the behavior of the developer that was the thought process of making it fast?
It's definitely something that's on our minds. And I think it was something we noticed internally, that it was like once we tried this out, people just seemed to like it in the company. And we thought that was a good sign. But you're right. I mean, I think we're seeing all kinds of different ways to use agents. With the new Cursor release, we have a very nice way of kicking off multiple agents on the same question. That's a really nice way of just getting a parallelism to try stuff out. We also have cloud agents, which allows you to run them offline or kind of while you're not watching them and do long-term changes or kind of change things as you go. So lots of ways to use them now, but we're still experimenting. We don't think this is the kind of final form factor.
What are you excited about next?
I mean, certainly the idea of just making better, smarter models is a really exciting area. I think even the last 6 months, we've seen this just get so much better. So I I think we'd like to kind of keep on iterating on that. But also things like having a faster model, how that allows it to work, supporting multiple models. All these things are kind of things on the front of our mind.
And as far as the trend with building for these AI workloads now, with kind of frontier models and all that, and is there like a certain advice you would give to engineers trying to build their own frontier model? What they should think about when they're building like right now with the challenges and the more agentic type use cases?
Yeah, it's a great question. Well, it's certainly hard. But I think the thing I'm most excited about is this idea that there can be specialized models in different use cases. One thing that's been really interesting to see is things like Thinking Machines released a nice API for doing RL. We're seeing versions of open source RL frameworks like SkyRL, I believe, is speaking here at the conference. And so I do think the kind of barrier to entry to doing kind of open source RL for different use cases will be an interesting thing going forward. And I expect there to be kind of more specialized models, kind of like Composer coming out. Yeah.
And how important are like open source libraries for all this?
Yeah. Extremely important.
We're here at Ray Summit. We love open source.
Absolutely. I mean, so things like PyTorch have been essential. Inference things like VLM, all this stuff is fantastic. We're big consumers of this, and I think it's amazing to see the work that people do in open source.
We're super excited. Well, I'm excited to use Cursor. I use it on the daily, and continue using Composer, and seeing all the updates coming up too. And excited for your talk tomorrow. We'll link it. Yeah. Any closing thoughts regarding Composer or anything else?
So I mean, it's exciting times. I do kind of think this idea of agents for different use cases is like just at its beginning part. I kind of caution that like getting really smart models in different areas will be a challenge, but I think we're making progress and it's cool to see it happen.
And we get to go to conferences and brainstorm all together and figure it out. So thank you so much. Thank you, Sasha, so much for being here.